If you haven't worked with Bayesian analysis before, dealing with prior probabilities and base rates, then the concept can be a little unclear. I'd like to work through a classic example from Tversky and Kahneman called the taxicab problem that will demonstrate how Bayesian analysis works and give you better intuition. Let's start with the facts as proposed within the problem. A cab was involved in a hit-and-run accident at night. There are two cab companies working in the city, green and blue. Furthermore, we know that a witness identified the cab as blue. However, 85% of the cabs in the city are green, and only 15% are blue. Next, we need to know about witness reliability. The court tested the reliability of the witness under the circumstances that existed on the night of the accident, and concluded that the witness correctly identified each one of the two colors 80% of the time and failed 20% of the time. If there are any attorneys watching this video, don't worry, this is merely an example, and it's not meant to be taken as a reflection of witness reliability in the real world. So your question is, what is the probability that the cab involved in the accident was actually blue rather than green? So we're looking at the probabilities for blue versus green. The answer might surprise you, and Neil Ocean, in an internet posting, provides an intuitive explanation of how to arrive at the correct answer, which is 41%. And you can find the answer at the website listed below. Let's walk through Neil Ocean's explanation of why the answer is 41%. We need to visualize the answer as a decision tree. At the top, we know that our base rate of cabs in the city are 85% green and 15% blue. The witness is 80% accurate, so if a cab is green, then the witness will say green 80% of the time and be correct, and will be wrong 20% of the time, meaning that the cab is actually blue. And we have the same for the blue side. If the cab is actually blue, then it will be guessed 80% of the time. If it's green, then 20% of the time the witness will be wrong. Now we take compound probabilities to see how likely it is we end up in each branch of this decision tree. So 85% of the time the cab is green, and it is guessed as being green 80% of the time. 0.85 times 0.8 is 0.68. Same thing for if the cab is actually blue, but it's guessed green. We have 0.85 times 0.2, which leads to 0.17. And then we have similar calculations for blue, leading to probabilities of 0.12 and 0.03. Now remember that the witness said the cab is blue, so we need to calculate the probability that the witness guessed blue when the cab was actually blue. So we use the two values in the middle where the cab was actually blue, and we get this calculation. 0.12 when the cab is actually blue, divided by 0.12 plus 0.17, which is when the cab is blue and was guessed blue, but also when the cab was guessed green, but was actually blue. So we have 0.12 divided by 0.12 plus 0.17, and that leads to a result of 0.41. In the next movie, I will show you how to create what is called a classification matrix so we can get the values that we need to perform this calculation in Excel.